Hi all. Yesterday during the live session there was a technical error in the recording. So what I'll do is I'll try to recreate it as much as possible. Okay. Yeah. Hello everyone. So my name is Neha, and yeah, and I'm currently pursuing my PhD at IIT Madras, and I'll be the TA for Discrete Maths course, and we'll have these sessions every Friday from 6 p.m. to 8 p.m. And typically, what we will do is we will have a set of questions based on the topics that are covered in that week, and yeah, and we will solve them so that they help you solve your assignments. And also, if you have any doubts throughout the week or anything, you can bring it up to me. And yeah, so I highly encourage you to discuss, or yeah, so to interact. So that's all about me. So the topics that we are going to do for this week are about counting. Okay, so we will look at the basics of permutations and combinations, and yeah, and we will look at the rules of counting. Then we will look at the binomial expansion and the stars and bars counting. Okay, so we will do a quick recap of this as and when we look at the problems of that kind. And if you want me to discuss the assignment solutions, then we can do it the next week. So you can let me know if there's any specific request you have. So feel free to let me know. Okay, so let's start with the question. Um, okay, okay, I see some message. 1 second. Okay. Uh, yeah. So, yeah. So there. Yes. Is there a question?
No, actually, we have been given a email ID or something to ask the queries from. So they will post the queries or what?
I couldn't hear you, but what I think what you're asking is you want uh, I mean, a channel for communication for the.
Yeah, yeah.
So you can there's this portal, right, for the discrete maths on Swayam. So there, I think there's a forum for specifically for doubt clearance. So I think students can also participate and the TAs can also participate. Also, these videos will be recorded, and I will be posting them on YouTube. So you can also comment there and let me know. You will have the access to it. So is that fine?
Yeah, yeah, okay, fine.
Okay, yeah, I do encourage you to interact throughout the course. So, yeah. Okay, I think there's a question from somebody else. Yeah, Mansi.
Actually, in the lectures, the tutorial lectures, I had a question which was solved, but I didn't quite understand it. So, can we just go through it once before starting, if you don't mind?
Could we take it up at the end so that everybody else sort of, I mean, goes in the same flow? Is that fine?
Okay, fine.
Okay, thanks. Yeah, anybody else? Okay. So, so I'll read out the question. So you have a box containing 12 black marbles and 8 green marbles, and the question is, um, yeah, in how many ways can you choose 3 black and 2 green marbles? So I'll let you think about it. You can type your answers in the chat. or you can unmute, and then we can discuss. Okay, I see one answer. Anybody else? Okay, so yeah, so good. Both the answers are correct. So yeah, so let's just recall what do we mean by permutations. And so permutations is basically the number of ways of choosing R objects from N objects where order matters. And the expression for this, which is very intuitive, is there are totally n factorial yeah. Okay. And if yeah, if you want to look at the combinations, then the only difference is that the order does not matter. So NC, I'll just write this as n choose r. This is n factorial by n minus r factorial, r factorial. So that's the expression you have, and you must have also felt that this is a very natural way of like how, the way we arrive at this is very natural. So now what we are asking is, let's say you have a bag with you have 12 balls and you have to choose 3 out of it. So these 8 are not even are just out of the question, because you can't choose a black ball from the set of green balls. So the number of ways of choosing a black ball is you have totally 12 balls, and you want to choose 3 of them. So that is 12 choose 3. And yeah, just a minute, I'll admit people who are in the queue. Okay. And similarly, number of ways of choosing the green balls would be you have totally 8 of them and you are choosing 2 of them. Now the question is, should we add them or should we multiply them? So what do you think? Should it be 12 choose 3 plus 8 choose 2, or 12 choose 3 times 8 choose 2? You can unmute and speak. Okay, so yeah, Akansha, Manasi, and Arush, all of them, they think you should multiply, which is correct, because you're asking, the keyword here is and. So that means you're asking number of ways of doing this and number of ways of doing this. These are independently different possibilities. So for every possibility here, you have a possibility here. So you're going to multiply. So when you say and, the rule is to multiply. When you say or, the rule is to add. So in this case we are saying and, hence you get you get 12 choose 3 times 8 choose 2, which is if anybody has calculated, you can also help me out. So this would be 12 into 11 into 10 divided by times okay, Neha says 6160, let's see. So this is 220 into 4 into 7. Yeah, 6160. Okay, so that is the answer. So the number of ways you can choose, in which you can choose 3 black and 2 green balls from this bag, is 6160, which is a pretty large number. If you think of it, I mean, this is a point that you must have seen in the lectures as well, where uh, you really have very small number of objects, and it looks like the number of possibilities of doing a task would be very small, but it grows exponentially. So understanding how to count is important, and it's not just about the balls and marbles, but it's very important. It's central to a lot of areas, and we will see their applications later on in the course. So right now what we are doing is we are just doing simple examples to understand the basics. Okay, so good, all of you. Okay. um okay, so let's look at, okay, yeah, are there any questions about the first example?
No.
Okay, so let's look at the second example. This is also simple. We'll start with simple examples. So let's say you have a club of 20 members, and you have a club of 20 members, out of which 9 are male, 11 are female, and you want to form a committee of, so you want to form a committee here, which is the shaded region, and you want 4 females and 3 males. The question is, how many ways can you do that? So this is also a simple permutation combination type question. So I'll just as a warm up, you can try this and you can share your answer, and we will discuss that. Okay, yeah. So Akansha says 11 choose 4 times 9 choose 3, which is correct. So basically, the number of ways of choosing 4 females from 11 is 11 choose 4, and the number of ways of choosing 3 males from 9 is 9 choose 3. And we are again, the question is whether to add these two numbers or whether to multiply. So we are asking, we want 4 female and 3 male, so clearly there is a and here, so you will apply the rule of multiplication. And that's why your answer is 11 choose 4 times 9 choose 3, which is what some of you have written in the chat. So I think I'll not get into the calculation of this for now. So I'll move on to the next question, unless there are any doubts.
I had a question.
Yes.
In this question, why did we not select the formula for permutation instead of combinations, because all of them are distinct persons, right?
Yeah, but as a committee, it does not matter whether you chose, let's say, okay, so let's say you have a group of friends. Let's say I'll call them A, B, C, D, and E. Let's say there are 5 people, and I want to choose 3 of them. So, does it matter whether I chose A first, B first, and then E? And so, do you treat this group and this group as different just because I selected A first here and E first here?
No.
Yeah, so that is, so whenever you're talking about a committee, the order does not matter. It's just a group of people who could have been chosen in any order. So that's why we are choosing combination. So it's a good question. Um, to distinguish whether when to choose a permutation and when to choose a combination. But if in the same question, if I would have asked that additionally I want to choose a head, I want to choose, there are positions in the committee. So let's say there are some rankings. So every rank is different. So in within the committee you have different seats, say S1, S2 up to S7. Okay, so now with that additional constraint, it's not the same as choosing A as first and B later, or B first and A later, because the seat also creates a difference. So in this case you would have chosen permutation because the order matters.
Okay, thank you.
Okay, good. Are there any other questions? Okay, good. So we will move to the next question. So, yeah, you have a word which is book, keeper, and the question is you want to rearrange them, all the letters, any way that you want, and we are asking how many distinct words you can form out of this. So, yeah, so maybe you can try this for some time. I'll give you a couple of minutes and you can tell me your ideas. Okay, yeah, good. I see a couple of answers in the chat. I'll wait for others to try for some time. Okay. Okay, so those of you who have answered in the chat, would you like to explain your idea? Okay, so yeah, so let's look at the solution. So let's count the number of letters here. So what is the number of letters you have? You have 10 letters. So the number of ways in which you could blindly rearrange the letters is 10 factorial. But this is not the correct answer because there are repetitions here. So for example, this O and this O, these are not, uh, so writing the third O first and the second, and the second O here, that should not be counted as different repetitions because those are essentially the same word. So we want to, so here we are over counting. That is, there are words that are being counted more than once because there are repetition of letters. So we want to get around that. So let's count how much excess are we counting. So what is the number of letter O's that you have? You have 2 repetitions of O. Then you have I think 2 repetitions of the letter K, and then you have 3 repetitions of the letter E. Okay, so yeah, so because you have 2 O's here, there are for every string there are you're over counting it twice. One is where you write let's say this is O1 O2, this O1 first and the second O2, and the other is swapped. So every word is, yeah, I'll admit this person. Okay, so every word is being counted twice for O, so we are going to divide this by 2 factorial. Same thing goes for K. For every choice of O, you're independently over counting K by twice, and same thing goes for E. So notice that this is multiplication because these over countings are independently done. So the fact that you are there are 2 repetitions of O is independent of the fact that there are 3 repetitions of E, for example. So this is not addition or something because for that reason. So is that making sense? Or are there any questions? Then please let me know. So yeah, this is your answer. Okay. Okay, so good. So then we will move on to the next question. Okay, yeah, and just anybody has anybody counted this number?
We have used the permutation as in the previous question, right? The same logic we used.
Sorry, I couldn't understand. Could you repeat?
I'm saying that you applied the same logic as the question which was asked in the previous question, right?
Yeah, as in the idea is same, that I mean, so the previous one, as in you mean the male female thing, the committee thing.
No. Over here, like you said, that the combination is not possible because they are like it is not like there is no specific order. You said, right? So
Exactly.
over here also, yeah. So over here also, like you applied the same logic, right? That there is no specific order, right?
Exactly. Yeah, that is correct. Yeah.
Okay, fine,
Okay.
fine.
Good. Yeah. Okay. Okay. So Sangeet says this number turns out to be, and Pranavi also says this number turns out to be 151200. So I haven't counted this, but yeah, thank you for the answer. Others, you can also check this out as an exercise. I don't know why. Okay. So okay. So I'll read out the next question. So you have this word combinatorics, and um, yeah. So the question is, in how many ways can you arrange this word such that the vowels are always together? So for example, you can have O I O A I followed by C M. Okay, so this is one valid answer because all the vowels are together, but this is also valid.
You can like group the vowels, not specifically in the starting, right? You can
Yeah,
do
it
it in
could
the middle
be
at the end also.
exactly. It could be anywhere, but the only thing is that it should be contiguous. So yeah, you can try this out for take your time. Then you can tell me your answer or ideas, and we can discuss this.
not as far as two combinations are made, one in the contiguous, which is there in the middle, and other one in the end. So the only thing which will be left is the rearranging of the vowels which you have done. So like the double O can come in the front, or the double O can come in the back, and the two I's can come in the front, and the two I's can come in the back. That's it.
Okay. So what is the expression that you are getting?
Yeah, I'm calculating that.
Okay. No, I mean just the expression, not the exact
Oh,
number.
okay. I'm calculating.
Okay. Okay, so anybody else has thought of so those people who have answered in the chat, would you like to unmute and tell your, because all of the answers are essentially different. So um, yeah, so I'm curious what your thought process is. Okay, this is confusing. Yeah, that is there. Okay, so what we will do is we will break this into small pieces and we will solve for each of them separately. Okay, so how many vowels do we have?
5.
Yeah, so you have 5 vowels and you have 8 consonants. Okay, and like yeah, sorry, I forgot you, Arush, I think. So like one of you was saying I mean the idea is that you think of the consonants as a block and you think of the vowels as a block. Okay, so suppose you want to look at all possible ways in which you can arrange these consonants. So how many ways there? So how many ways there would be? This question is exactly what we answered here in the bookkeeper question. You're just asking how many ways you can rearrange them so that you have distinct words. So number of ways of rearranging the consonants. Yeah. Yeah. So you agree, right? The question that I'm asking, the first question that we are breaking this into parts. First question we are trying to answer is how many ways you can arrange the consonants only. This okay. There are different answers. Okay. Is the question clear or do you want me to repeat? Okay. Anybody else? Okay, a lot of yeah, I think Akansha, your answer is correct for vowels. Uh, what I'm asking right now is for the consonants. So, um, yes, that's no. Think yeah, one of you have got it. So the answer is 8 factorial divided by 2 factorial. So most of you guessed 8 factorial, which is because there are 8 consonants, and you can arrange them in 8 factorial ways. That is correct. But notice that we have to account for the repetitions. So in this case, this letter C here and this letter C here is repeated, and we don't want to overcount for the repetitions. So we have to divide it by 2 factorial. Is this okay?
Yes.
Okay. Okay, good. If anybody has any other answer or you feel this is not correct, then let me know. Okay, we can discuss.
Should
No,
like
no,
the
okay.
8 factorial thing, the 2 factorial thing I didn't got.
8 factorial. Okay.
No, the 2, 2, 1, 2, 1, 2,
Divi-
1.
um,
The vowels one, like the 2 factorial.
no, this 2 factorial is not for vowels. So vowels is out of the picture right now. We are only focusing on consonants. Okay. So what are the consonants? Let's write that down. You have a C, then you have a B, then M, N, T, R, C, S. These are the 8 consonants that you have, and 8 factorial is the way in which you can arrange. But notice that this C and this C is repeated. So you don't want to count these repetitions. So this and this, these are getting over counted in the factorial, right? Because it cannot distinguish between this C and this C. Is that okay?
Yeah. So,
Okay, so we are over counting by a factor of 2, that's why we are dividing by a factor of 2. So now if that is
okay.
okay, yeah, good. So now if that is clear, my question 2 is, what is the number of ways in which or of rearranging the vowels? Okay, okay, good. So I think yeah, all of you got it. So yeah, answer is 5 factorial by 2 factorial by 2 factorial, because you have 5 vowels, which is I, O, O, A, I. And out of this, you have 2 repetitions of I and you have 2 repetitions of O. So out of 5 factorial, you have to divide by 2 factorial and 2 factorial, accounting for the repetitions of I and O. So good. So now we have partial answers to the problem that we want to solve. Now the question is, where can the block of vowels be? What is 2 factorial that I could you explain? Oh, okay, no problem. Yeah, exactly. So there are 9 places where you can put the vowels. So let's see how. So Okay, so these are the consonants that we have, and now I have a block of vowels. It could be arranged in any way, and this is just one particular way of writing the consonants. There are I think 8 factorial divided by 2 factorial many ways. I'm just looking at a particular arrangement. For this arrangement, where can it be? The block can be here, so you can have your block followed by the consonants, or you can have C and you can insert your block here, and you can keep on doing this C C. And so basically you can put it here, here, or at the end or at the beginning. So totally there are 9 places to 9 ways to place a block of vowels between a string of consonants. Is this okay? Okay, so now we broke it into 3 questions. So this was the third question, is how do you place the vowels. So now you have answers to all the 3 questions. Would anybody like to combine and tell the final answer? I mean just the expression, not the value. Okay, yeah. No, I am not sure by. Okay, 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 okay. So let's see the answer. So, what we are doing is our answer would be number of ways of arranging consonants. Okay, multiplied by number of ways of, or let's say, of placing the block of vowels times number of ways of arranging the vowels. So basically we are saying that you look at the consonants and arrange it in all possible ways. Now once you, for every setting of consonants, there are 9 ways in which you can place the block of vowels. And then how many ways can you arrange this block of vowels? So this was 5 factorial by 2 factorial 2 factorial. This was 9, and this was I think 8 factorial by 2 factorial. So yeah, so this is again the rule of product. You are just multiplying all the 3 answers because all 3 are independent. So yeah, I think most of you got this answer, but anybody who had a different answer, if you want any clarification, then yeah, this is a good time to ask. Okay, good. So yeah, so I just want to make a point here that whenever you come across a problem of counting, or anything, not necessarily counting, which looks complex, most of the times the way to attack it is you break it into small pieces you answer them individually, and then you see how you can combine them. In this case it was yeah, I'll get to it. So in this case it was I mean, it was just that you had to multiply, but it could be different for different cases. But generally, when you see that something is confusing, it's because there are lots of components that we are looking at, and if you can try to solve them individually and put them together, that is yeah, that would work a lot of times. So yeah, that's just the general thing I wanted you to take away. Uh, Now there is some question. Okay, why is it 9, not 9 factorial, but 9? Okay. All we are asking is how do you place a block, right? So you can think of um, um, okay, like okay, I just want to understand what is the logic behind 9 factorial. Could you write it or unmute?
Ma'am, in the answer 8 factorial into 9 is 9 factorial. So multiply and combine, we can write it 9 factorial by 2 factorial into 5 factorial by 2
Oh,
factorial into 2 factorial.
oh, okay, okay. Yeah, yeah. So this is what you are saying. That 8 factorial into 9, you can write it as 9 factorial.
Ma'am, it was not about that, but the 9 factorial, isn't it about the ways of arranging though, like the different combinations you can make? Is it not 9 factorial though?
Uh, the number of ways in which you can place the block of
Well,
vowels.
yes, ma'am.
Okay. So okay, good. So let's clarify that. So what we are saying is you have one block of vowels, right? So there's only one place where you can keep it. So 9 factorial is something that you do when you have um, let's say you have 9.
Ma'am, maybe you are trying to say that 9 factorial is like arranging the block of that nine letters into some different ways which we can't do it. Am I right?
Yeah, yeah, yeah. That is exactly what I'm trying to say. So 9 factorial is something you do when you want to let's say arrange. You have 9 different books, let's say, and you want to put it in your shelf, and you want to look at how many ways you can do. So first book you can put in 9 ways. Um, and I mean in one of the 9 places. The second book you can put in one of the remaining 8 places, the third in the one of remaining 7 places, and so on. But in this case, think of this block of vowels as a single book that you have to keep, because it's a block that we are looking at. There's only one block and you have to put it in one place. So there are
Oh,
only
yes, ma'am, I got it. Thank you,
okay,
ma'am.
okay, good. So yeah, are there any other questions? Okay, so good. So let's move on to next question. So this is something that you might have done this week, right? Have you done what is called binomial coefficients? Okay. Okay. uh, okay, okay, yeah, Nikhil has raised a hand. Would you like to speak? Okay. um, okay, so I have a set of questions about binomial coefficients, but we will do them together. I mean, okay, I'll admit one more person. Okay. Okay. So What I'll do is I have a set of questions on binomial coefficients that I'll do after we do the simple counting parts. Yeah, someone is asking if binomial coefficient is there in week 1. Okay, I'm not sure, but from what I remember it was there, but I'm not sure. So that's why I'm pushing it at the end. But I'll recall all the concepts that are needed. So whenever we do a problem, okay, good. Thanks for the clarification. So that's the general thing I'll try to do anyway. If you miss out a lecture for some reason, I'll try to give a small recap of the concept and then we'll solve the problem. Okay. So this question is not related to binomial counting. So let's try to solve this. Okay. So you have yeah, you want to buy 8 fruits, and you have options of you can choose apples, bananas, pears, and oranges. So for example, you could take 2 apples, then you could take 3 bananas. Then let's say I do not want okay, and let's say I don't like pears, so I do not want any pear, and then I have to take 8 fruits, so I'll take remaining 3 as oranges. That is just one way of taking. And um, yeah, you could have so many ways. So the question is, how many ways can you do this? Okay, so I think, yeah, most of you have got it right. So the answer is 11 choose 3. And let's say, how do we arrive at that? So this is what is called stars and bars counting. And um, the problem is that you have n stars and you have k bars, or you want k partitions. So let's say I have these many stars and I want to make 3 partitions of them. So I could put 1 star in one box. I could put 3 stars in one box, and then I could put the remaining 2 stars in the other box. Or you could also do this. You could keep this empty, and yeah. So what we have done here is sorry, yeah, this partition is empty, this partition is empty, and you have put all the stars into one partition. That is also allowed. So the question is, how many ways can you do these partitions? And uh, you can think of it this way. So also, yeah, notice that if you want to make k partitions, how many bars do you want would you have to put? Yeah, that's right. So if you want k partitions, you just need k minus 1 bars, because if this is what you have, if you put a bar here, that it already divides it into 2 partitions. So you just need k minus 1 bars. So that is same as asking that I have uh yeah, I have I have some space where there are n plus k minus 1 let's say blanks, and I could either put a star into it or I could put a bar into it. If I put a star, it means it's into that part, it's into the bucket. If you put a partition, it tells you where the partition starts. So you could put so you have n plus k minus 1 um, space, and you want to put n stars into it, or you can also think of it as you want to put k minus 1 bars into it. Okay, so how many ways can we do that? Okay, so my claim is you can do this in n plus k minus 1 choose n ways, which is same as n plus k minus 1 choose k minus 1 ways. So yeah, right. So is there any clarification about the stars and bars counting? If that is the case, then let me know. Okay, so yeah, so that is it. And now all you have to do is you're just going to apply this formula by identifying what are the stars and what are the bars. So in this case, yeah, so in this case you have 8 apples, sorry, what you have 8 fruits. I mean, you want to put 8 fruits and pick 8 fruits, and you want to choose which of them are apples, how many of them are pears, and so on. So basically, you want to put 3 partitions because you have 4 varieties of fruits. So you want to put 3 bars, and so your n is 8 and k is 4. So what is the answer you get? N plus k minus 1 choose k minus 1. This is same as 11 choose 3. So this turns out to be okay. Is this what others are also getting? Okay, good. So yeah, okay, if there are any questions about this problem, then yeah, you can ask me right now. Otherwise we will move on to the next question. Is there a question, Sangeet?
No, ma'am.
Okay, sure. So, yeah, I just wanted to announce that all this, I mean, the PDF of whatever we do, the solutions, or I mean, the rough work that we do, this would also be uploaded in the drive, and you can access it from the same portal. Um, Also, yeah, so while these videos are recorded and it's accessible to you, I encourage you to join online so that we can have discussions, and rather than you just watching it. um, I mean, of course, I mean there may be constraints, but I would encourage you to join um, if you have time. Okay, so yeah, our okay, okay, yeah, sure, no problem, yeah. Yeah, so as much as possible, I'll try to assume that you have not watched the lectures. Although I mean, if you have time, you could, but I'll not assume a lot. I'll try to give a brief recap, so that even if you have not watched, you can try to connect. Okay. So yeah, so if that is clear, yeah, maybe you can try this question. So the question is, you have an equation which is x1 plus x2 plus x3 is equal to 10, and the question is how many non-negative solutions there can be for x1, x2, x3. Okay, so those of you who have got the answers, would you like to explain? Okay. Okay, good. So I see all. Yeah, yeah, that is right. So yeah, the idea is correct. So um, the idea is you use the same stars and bars counting method. Only thing you have to do is you have to identify the stars and you have to identify the bars. So what are the stars in this case? The stars are, I mean, how many stars are there? So let's say there are 10 stars, and these are 10 of them, and x1 is like putting x it's like putting x1 stars into the first partition, putting x2 stars into the second partition, and x3 in the remaining one. And because x1, x2, x3 are positive, or I mean they are non-negative, you can use the stars and bars counting. So this is the k, sorry, the k for us is 3 because you want 3 partitions, and n for us is 10. So by directly putting into the formula, you get this is 12 choose 2, which is 66. So which is the same as what all of you have also got. Now the question is, what do you think would happen if I allow any, yeah, if I allow any solutions here, I don't put this x1, x2, x3 greater than equal to 0 constraint, then what do you think would happen? Yeah, exactly. You would have infinitely many solutions if I allow them to take negative numbers as well. So yeah, so when you have these negatives, I mean non positive, okay, like, okay, when you have that the variables can take negative values, you typically can't use this standard counting formulas. So these work. So even though we write them in general, there are uh, there are constraints that are there. Those are implicit and we don't say it. So you can't directly plug and place things into the formula as long as they don't satisfy it. Yeah. Okay, so that is all about the counting part. So what we did so far is we saw some examples of permutations, combinations, and rules of product, and now we saw the a new method which is stars and bars counting, and we saw a few examples of them. Now I'll move on to the question I asked you earlier. So here is the binomial coefficient question. So yeah, so it's possible that some of you uh, may not have watched the lectures, but I would still like to give you some time to think about it. But if there is anything about the question that is unclear, then yeah, then do let me know. Okay, I see some answer. Okay. Yeah, I think that is okay. Yeah, anybody else, or um yeah. Okay, yeah, that is right. So let's see. Okay, we will uh, start by just a quick recap of what the coefficients are. So so let's say um, you have an expression like this. So what that means is you are basically multiplying this set n times. Okay, and what are the terms that you would get? So if you choose, yeah, if you choose x from the first set, x from the, I mean, basically you take x from all the n sets, then what is the term you get? You get x to the n. Now what is the number of ways to get x to the n times y? So is the question clear? So let's say I just had two of these here, and I'm asking you what is the coefficient of xy here. So what would you do? You can either take this xy, this is nothing but x square plus xy plus yx plus y square, and this is x square plus 2xy plus y square. So the coefficient here is 2. So I'm asking you, in this general setting, what would be the coefficient of x to the n minus 1 times y? Is there anything that is unclear about the question? Exactly. So you have n choose 1 base, which is that yeah, which is that you want to choose one y, and you can pick it up from this set or this set or this set. So you have n many choices. So yeah, so you want to pick one y from n choices, so n choose 1 is what you get. Similarly, if I ask you what is the coefficient of x to the n minus 2 times y square, that would be n choose 2, because it's same as asking in how many ways can you choose 2 y's from a set of n y's. So you get the idea what the expansion would look like. So this is same as n choose 0 x to the n plus n choose 1 x to the n minus 1 y plus n choose 2 x to the n minus 2 times y square, and so on, and n choose n y to the n. Okay, so yeah, so if you try to write this as a summation, what would it be? It would be summation of n choose I x to the n minus I is from 0 to n, y to the I. Is this okay? This is just a closed form. Okay, good. Okay, so now what we are asking is, in this expansion I want to find the coefficient of the first term, or let's say the rth term from the beginning. So looking at this, what would be the coefficient of the rth term from the beginning? Exactly. So the coefficient would be n choose r minus 1, because the coefficient of first term is n choose 0. So there's a minus 1 thing that's happening here. So the rth term would be n choose r minus 1 x to the n minus r plus 1 y to the r minus 1. So is this okay? Or are there any questions about this? Okay, good. So yeah, so now given this, we are just going to plug and place our the values into our formula. So what we will do is, we want fourth term from beginning, so that is
Like, could you show the last part? I was noting down.
yeah, sure.
Yeah, please wait for 10 minutes.
Yeah.
Yeah.
Okay, so for us n is okay, n is 9 and r is 4. So our coefficient is n, our term is n choose r minus 1. So x is, this is what I hope this is clear, that this is what x is, and this is what y is. So this is x cube by 2 plus minus 2 by x square to the 9. I hope this is fine. So this is like x and this is like y for us. So x cube by 2 to the n minus r plus 1 and minus 2 by x square to the r minus 1. Is this fine? What we did is we just plugged and placed the oh sorry, okay, thank you for pointing out. So okay, the question is fourth term from the end, so I'm using the wrong formula. Okay, okay, so the question is what is the fourth term from end. So notice that rth term from beginning is n minus, okay, I'll let you feel this, is what term from end. So essentially what I'm asking you is you have a bunch of numbers, and if you start counting from here, then let's say it's k, then what would the number be if you would have started counting it from end? Okay, so I have two answers and one of them is correct. So anybody else has anything to say about this? Is it n minus r plus 1 or n minus k plus 1, or is it n minus k? Okay, so yeah, exactly, it's plus 1 because as a simple example, if you're looking at first term from beginning, then it is the nth term from end. So okay, so your answer is n minus k plus 1 term from n. So what we will do is so we will write this, we'll put this into the formula that we had here. So you have n choose n minus r plus 1 x cube by 2 to the r minus 1 times minus 2 by x square to the n minus r plus 1. Okay, is this fine? Okay, so let's put the values. N was 9 and r was 4 for us. So what is this? This is 9 choose 6 x cube by 2 to the 4 minus 1, which is 3, minus 2 by x square to the 9 minus 4 plus 1, which is 6. Is this okay? Okay, so I'll just say one thing. So what we did is we observed that rth term is nothing but from end is nothing but n minus k plus 1th term from beginning, and we simply uh, placed it plugged and placed it into r. So instead of r, we are saying n minus r plus 1, and we just uh, yeah, we're just putting it in there. Okay, I think there's a minus 1 here. So this would be okay. So if you solve this, you get n choose 5 x to the um, x to the 9 by 8 times 64 by x to the 12. Okay, so okay, I'm not expanding it further, but if you want, you can do and you can see what is the number. But yeah, I'll leave it there. But if there are any questions about any point here, then let me know. Okay, so we will do one more example of this kind. So here the question is slightly different. You are given this you're given this expression, binomial expression, and the question we are asking is find a term which is independent of x. What do I mean by that? Um, okay, what is the question here? Total 10 terms from last means 7th term. Okay, I'm not sure. Is this about the previous question? Okay. We had 9 terms, right, totally? Oh, sorry. Okay. Okay. You are right. So totally there were 10 terms, because if you look at this expression, um, I mean, okay, let's say this is x plus y whole square. Then when you expand this, you actually get 3 terms. So so if the power is n, then the number of terms here would be n plus 1. So okay, is this making sense? Okay, so that means you are yeah. Okay. So I mean, your point is correct, but I don't think that affects the calculation, right? Because we accounted for it in this counting itself. Okay, maybe what I'll do is I'll do this part again. So okay. Okay, so yeah, so you have that okay, you are looking at x plus y to the n, and we said that rth term from beginning. Okay, I'll not write it again. So this is the point that we made, and we have 10 terms totally, because in this case n is 9. So if you are looking at fourth term from beginning, that would be 10 minus 4 plus 1, which is seventh term from end. So that point is valid, the thing that you've written in the end. Okay, so what we are essentially doing is we are looking at n choose r minus 1, x to the n minus r plus 1, y to the r minus 1, with n as 9 and r as 7. Okay, so this gives you 9 choose 6, and x for us was x cubed by 2 to the okay. Yeah, 9 minus 7 plus 1, and y was minus 2 by x square, and r is 7, 7 minus 1. Is this what you're getting? Okay. Okay, so okay, so okay, in the expansion of a plus b to the n, the rth term from end is okay. So okay, I don't know the pronunciation for your name, but the person who commented, I mean, who wrote in the chat. So is this the same as what you're getting, this expression? Okay, so okay, so what we will do is we will do this part by part now. So is everybody okay with this part? Okay, is everybody okay with this part, that the rth, this is the rth term from beginning? Is this fine, or is there any okay? Now the next thing that we said was uh, yeah, if you're looking at rth term from beginning, then it would be n minus k plus 1th term from end. Okay, so this is not clear. Okay, so let's look at this. So let's say you have n terms here, and you are looking at rth term from beginning. So what would it be from the end is the question. So let's say r is 1, then the first entry, then the first block, if you start counting from the opposite end, what would the answer be? it would be the nth term, right? From end. Is this fine? Yeah, I agree with you totally. There are n plus 1 terms, but okay, this n is different from the n that I was talking about. Maybe that is the confusion. So is this okay now with a new n? Okay, so if you have n terms here, then rth term from beginning would be n minus r plus 1th term from end. Is this okay with everyone? Okay. And now the thing that was pointed out was, if you have x plus y to the n, then the number of terms that you see here is n plus 1. So that's why you have capital N is equal to n plus 1. Is this fine? Okay. So hence, what you are looking at is your small n is 9, r is 4. So you're looking at 9 minus 4 plus 1 term. Sorry, this is 10. It is n is 9 plus 1, which is 10, and n minus r plus 1 would be 10 minus 4 plus 1, which is 7. And so we will plug this into it, and then you get 7th term from, so you take r equals 7 and n equals 9, and then this is what you get. Okay, so I hope this is fine with everyone. I think there was something I missed out, so sorry about the confusion, but I hope this is fine now. Or is anyone confused about it? Okay, good. So I'll just expand this so that you can match your answers. It says n choose x cubed by 8 times 64 by x to the 12. So yeah, I'll leave it there. So yeah. Okay, so if there are no questions, then I'll move to the next to the next one. Okay. So what I mean by term independent of x here is that you do not have so something like this. Something like this depends on x clearly because it's an expression written in terms of x. So if you have anything here that depends on x, then the term is dependent on x. So anything which is a constant is a term which is independent of x. So that is exactly what the question is. Can you find a term here which does not have a factor of x into it? Okay, I see one answer in the chat. Anybody else? Okay, so okay, so there is a doubt. I'll address that. Okay. Okay, so yeah, so to answer that, I actually wanted to discuss this with you. Would you prefer um, questions about the current topic being discussed, which will help you solve the assignments, or would you prefer discussing solutions to the previous assignments, or do you want a combination of both? You could let me know in the chat. So someone has asked what would be the content in the next. No, so previous would mean okay. So if we are in week n, then we would discuss solutions to week n minus 1, which is something that you have already submitted. Okay, so someone says combination. Okay, so if you have any, okay, yeah. So a lot of people say combination. So if you have any specific questions, you could use the portal, and you can use the chat. Then I'll prefer to take those questions which you want me to take. But yeah, please let me know in advance if you want that to happen. So also we can change the model throughout the course, depends on what you guys prefer. Okay, so okay, so coming back to the, yeah, to the binomial question. Okay, yeah, so I'll keep that in mind. If there are different questions, I'll try to bring them. Okay. Okay, so yeah, is there anything else before we move on to the binomial question? Does anybody have any other question regarding the discussion we just had? Okay, so we will move back to come back to the question. So a lot of you have answered third. Yeah, so the third um, would be n min sorry. Right, so what you get here is square root x to the 8 divided by x to the 4, which is x to the 4 by x to the 4, which gets cancelled off, so you just get a constant. So that answer is correct, but how do we arrive at this? So answer is third term, which most of you answered. So how do we get to it? We will use the same formula. So rth term is n choose r minus 1, x to the n minus r plus 1, and y to the r minus 1. So yeah, so in this case what that sorry, yeah, I'll maybe erase this. Okay, so in this case what that accounts for is you have 10 choose r minus 1 times x is square root x by square root 3 to the 10 minus r plus 1, and then you have minus square root 3 by 2x square to the r minus 1. And if you look at the coefficient, yeah, sure. So those of you who need to leave, please feel free to leave. That's not an issue. Okay. Okay. Okay, I think there's some error that happened on the recording, so I'm not sure if this session got recorded, but okay, I'll look into it at the end. Okay, so okay, coming back to this, so what we want is we want the coefficient of x to be 0 so that the term is independent of 0. So that is x to the I'm just looking at the x terms right now. 10 minus r plus 1 divided by x to the 2r minus 2, and this is nothing but, and we want this to be 1. So that is, you want 10 minus r, or let's say 11 minus r by 2 to be equal to 2r minus 2. And if you solve for this, you get 11 minus r is 4r minus 4. So this gives you that 15 is equal to 5r. That gives you r is equal to 3. So you essentially want the third term. So yeah, so that is the, yeah. So okay, is there any question, is there any clarification you need about this, or was this fine? So what we did was we basically looked at the rth expression, and then we equated it to 0 for the coefficients of x. Okay, so yeah, I had one more question, but I think I'll take it up next time. Since it's the first session, I think, yeah, we can end it for now. And okay, I think I still need to look into the recording, whether this got recorded or not. But okay, I'll find that out. Okay, if there are any other questions, then let me know. I mean, about whatever we discussed. Okay, so that is all for today. Our next session would be on next Friday, same time, 6 p.m. to 8 p.m. Yeah, so next time we can discuss solutions to problem set, and we can look at some new problems, some new topics based on that week's content. Yeah, I think that is all for today. I'll see you all in the next week. Okay, thank you all.